We're now going to take a look at trigonometry for right-angled triangles. First part in doing this is identifying the sides. So here's our triangle with the angle marked. The hypotenuse is the longest side in the right-angled triangle, and you probably know this from the work you've done with Pythagoras' theorem, so it's not a problem. Always the longest. The opposite is the side which is opposite the chosen angle. So it doesn't touch it, it's opposite. And the adjacent is the side between the chosen angle and the right angle. Now, copy these diagrams, identify the hypotenuse with an H, the opposite with an O, and the adjacent with an A. So here are the triangles. What I'd like you to do now is pause the video and then restart it when you're ready to give the answers. Now, the hypotenuse, longest side on each of the triangles. Opposite. Opposite does not touch the angle. Adjacent is the one between the angle and the right angle. Now in trigonometry there are three ratios you need to know. First one is sine, S-I-N. Second one is cosine or cos. And third is tangent or tan. The sine ratio. Here's our triangle. Sine of the angle is defined as the opposite over the hypotenuse. Let's consider some examples. Here's our triangle. The hypotenuse is 13 centimetres. The opposite is 12 centimetres. So sine of the angle is opposite over hypotenuse, which is 12 over 13. In the next one, we have a hypotenuse of 32 metres, an opposite of 20 metres. So sine of the angle is opposite over hypotenuse, which is 20 over 32. And in this case, we have one which actually simplifies down to be 5 over 8. The cosine ratio. Here's our triangle again with the A, the O and the H all on board. Cos is defined as the ratio of the adjacent to the hypotenuse. So here we've got some examples. Here's our triangle. We have a hypotenuse of 13 centimetres and an adjacent of 5 centimetres. So cos of the angle is A over H, which is 5 over 13. In this one, we have a 7 metre base. We have a 32 metre hypotenuse. So cos of the angle is A over H, which is 7 over 32. Tangent ratio. Here's our triangle again. Tan is defined as the opposite over adjacent. So we've got some examples. Here's our triangle. We have an opposite of 12 centimetres, an adjacent of 5 centimetres, so tan is going to be O over A, or 12 over 5. Next example, we have an opposite of 19 metres, an adjacent of 5 metres, so tan is opposite over A, which is 19 over 5. Remembering the ratios. Sine is opposite over hypotenuse, so that gives us so. Cos is adjacent over hypotenuse, gives us car. Tan is opposite over adjacent, so that's toe, ah. So that's the important part. The so, car, toa. So, car, toa. Now, it's important to know that tan is the only ratio that can be greater than 1. Because if you think about sine and cos, both of those have two sides that are smaller than the hypotenuse, so they must always be less than 1. You've got some more to know too. Let's consider sine of theta divided by cos of theta. we put this in, that's O over H divided by A over H. Now you know when dividing fractions, you keep the first one the same, turn the divide into a times, and flip the other one upside down. So we get something looks like this. So sine theta over cos theta is equal to O over H times H over A. But we can cancel the H's. So sine theta is O over A. And if we think about it, that's exactly what tan is. So in other words, tan theta is sine theta divided by cos theta. Understanding angles. Now, you already understand that there are 360 degrees in a revolution, and degrees are shown with a symbol, sort of like a superscripted 0. Each degree is divided into 60 minutes, and minutes are shown with a single little superscripted dash. Each minute, as with time, is divided into 60 seconds, and the minutes are shown with a double dash. Okay, let's continue with looking at and understanding our angles. When rounding angles to the nearest degree, 0 minutes to 29 minutes do not change the degrees. It's less than halfway. It's the same sort of thing that if you have 3.4 meters and you're rounding to the nearest meter, it's 3 meters. Whereas if you had 3.5 and you're rounding it to the nearest meter, it goes up. So the 30 minutes is half of the degree. So you now change anything that has got minutes of 30 to 59, you change the degrees. So in our first example, 37 degrees 29 minutes is rounded to the nearest degree to be 37 degrees. Whereas 21 degrees 30 minutes is rounded to 22 degrees because the 30 minutes is past halfway. Now, you can get the pattern on this, that when you're rounding angles to the nearest minute and you're looking at the seconds, no seconds to 29 seconds don't change the minutes. 30 seconds to 59 seconds changes the minutes. So 57 degrees, 49 minutes, 25 seconds is rounded to 57 degrees, 49 minutes. The 25 seconds don't change the degrees. Whereas if I've got 23 degrees, 15 minutes, 38 seconds is greater than 30, so it's rounded to 23 degrees, 16 minutes. Degrees, minutes and seconds on your calculator. The button you're looking for, generally, has got the 3 symbols on it. So you've got the degrees, minutes, seconds button. This will switch between the degrees, decimal ways of looking at degrees, to degrees, minutes and seconds. So if I put in 52.63 degrees and press the button on the calculator, it goes to 52 degrees, 37 minutes, 48 seconds. And if I press it again, it goes back. Let's now look at trying to solve problems using trigonometry. The most important step in this is to actually identify correctly the HO and A for the angle involved, because once this step is completed, there's only 3 types of problems. The first thing is getting the correct ratio, whether it's sine, cos or tan, and you do that using the HO and A. Types of problems. Unknown numerator. So you've got sine, cos and tan. In this type of problem, we're looking at the O for the sine, the A for the cos, and the O for the tan. So unknown numerator. Identify the HO and A that matches the problem. So here we have a problem where the H is 17, the A is X, so we know using A and H we have to use cos. So cos of 35 degrees, important to write it down this way, cos of 35 degrees is the X over 17. So you're using the definition of cos to create the equation. The next thing is that when you've got a divided by, such as x divided by 17, you know that you multiply the opposite side by the 17. So our next step comes 17 cos 35 degrees. Now you use your calculator and you find that to one decimal place x is equal to 13.9. So with an unknown numerator, if you've identified that the ratio involved is sine, then sine is used in each step. If you've identified that the ratio involved is cos, then cos is used in each step. And of course, if you've identified that the ratio involved is tan, then tan is used in each step. Consider the following. We got 3 examples here. In each of these, the first on the left, we've got the opposite is x and the hypotenuse is 10. In the second one, we've got the adjacent is y and the hypotenuse is 15. In the last one, we've got the opposite is q and the adjacent is 150. So, starting off, we have the 3 of them. Sine in the first one is x over the 10. Cos in the second one is y over 15. Tan in the third one is q over 150. You'll notice, again, all of these are the unknown is on top. So now we've got these unknowns divided by a number. So we multiply that number on the opposite side, and I'll switch it around just so it makes it look nice. So in the first one, x is 10 sine 35. In the second one, y is 15 cos the 47. And in the third one, q is tan 7 degrees. So we put those in the calculator. In the first one, we get 5.74 centimeters. In the second one, we get 10.3 meters. And in the last one, we get 18.42 meters. And you can see how when we're using sine, cos and tan, the process is identical. Unknown on top, multiplied by the number underneath, using the ratio that's relevant. So let's take a look at our types of problems. Here we're going to be looking at unknown denominator. So in the case of sine, it's the h. In the case of cos, it's the h. In the case of tan, it's the a. Unknown denominator. As with all of these problems, the first step is to identify the h, the o and the a, and then use the ratio that matches the problem. So here's our problem. In this case, we have an a and an h relative to the angle of 35 degrees. So we have to use cos. So cos of 35 is 67 over y. So multiplying both sides by y, we get y cos 35 is equal to 67. So y is going to be equal to 67 divided by cos 35. Cos 35 is just a number, so you know that, like if you had 3 times y is equal to 15, then y is going to be 15 divided by 3. It's working the same way. So use your calculator, and you'll find that y is equal to 81.79 centimeters to 2 decimals. So continuing on with unknown denominator, if you've identified that the ratio involved is sine, then sine is used in each step. If you've identified that the ratio involved is cos, then cos is used in each step. And of course, if you've identified the ratio involved is tan, then tan is used. So we're going to consider 3 different problems. One with sine, one with cos, and one with tan. So in the first one, sine 83 degrees is 12 over a. Second one, cos of 36 degrees is 30 over k. And in the last one, tan of 3 degrees 16 minutes is 75. So we multiply both sides by the unknown. So in the first one, we get a sine 83 degrees is 12. In the second one, we get k cos 36 degrees is 30. And in the last one, we get p tan 3 degrees 16 minutes is 75. So we now divide by the sine, cos, or the tan, which they're only just numbers. So a is going to be 12 divided by sine 83 degrees. K is going to be 30 divided by cos 36 degrees, and P is going to be 75 divided by tan 3 degrees 16 minutes. We use our calculators and we find that A is 12.09 metres to the nearest metre. K is going to be 37.08 centimetres to the nearest two decimal places. In the last one, we're talking metres, so having it to a number of decimal places is probably not important. So in this one, we've rounded it to the nearest metre, so it's 1314. Now, when you're showing your working to show you understand this, you don't really need to show that middle line. And it basically says that when you've got a problem like sine 83 degrees equals 12 over A, you can swap the A and the sine 83. Or you've got the cos 36 degrees is equal to 30 over K. You can swap the K and the cos 36 degrees. When you've got tan 3 degrees 16 minutes is equal to 75 over P, you can swap the P and the tan and you get P is 75 over 10. What I wanted to demonstrate in this as to why it is so. But when you're working, you don't have to show that middle step. Okay, now let's take a look at our third type of problem, unknown angle. So you've got sine of the angles, O over H. Cos of the angle is A over H, and tan of the angle is O over H. Unknown angle. The first thing always is identify the hypotenuse, the opposite, and the adjacents, HOA, and then use the ratio that matches the problem. So here we have a triangle, and we've got an unknown angle. We have our A is 67, our H is 95, so A and H use cos. So cos of the angle is 67 over 95. So we're going to take the cos to the opposite side and use what's called an inverse function. Understand inverse function. If we say cos of an angle, you put it in your calculator and tell you what the ratio is for that angle. If we're using cos to the minus 1, which you get by doing shift cos on your calculator, it says, I know the ratio, tell me the angle. And that's what the inverse function's for. So, use your calculator, and you find it's 45.1491919 degrees. Press your degrees, minutes, seconds button, and you find it's 45 degrees, 8 minutes, 57.09 seconds. We want this one rounded to the nearest minute. So we look at our seconds, 57. Definitely bigger than 30, which is halfway. So 45 degrees, 9 minutes. So when working with the unknown angle, if you identify that the ratio involved is sine, then sine or sine to the minus 1 is used in each step. If you've identified that the ratio involved is cos, then cos or cos to the minus 1 is used in each step. And if you've identified that the ratio involved is tan, then tan or tan to the minus 1 is used in each step. Consider the following. Again, I'm going back to having the three different problems, and you can see how each one of them works in identically the same way. So step 1, identify your main ratio. So in the first one, sine of the angle is 13 over 25. In the second one, cos of the angle is 11 over 18. In the third one, tan of the angle is 83 over 207. So we now need to move each of those ratios to the other side to say, in the first one, theta is going to be sine to the minus 1 of 13 over 25. In the second one, theta is going to be cos to the minus 1 of 11 over 18. And in the third one, theta is going to be tan to the minus 1 of 83 over 207. Recommendation. I know mathematically we usually tell you to simplify fractions. Don't worry about it. Your calculator will do it all for you. Okay. So when we put these into the calculators, we get these decimal degrees. Now if you're rounding to the nearest degree, you can use decimalisation to do that for you. But if you want to round to the nearest minute, you've got to press your minutes, degrees, minutes, seconds button. And so we get these. So in the first one, we have 31 degrees, 19 minutes. You got 56 seconds. 56 seconds is going to round up, is closer to the next minute up. In the second one, we've got 48, and that's going to be greater than 30. So we're going to round up the 19. In the last one, we also have one where it's 35 greater than 30, or greater than 29 actually, so 30 or bigger, so we're going to round up. So when we do the final problem, first one comes up 31 degrees, 20 minutes. Second one comes up 52 degrees, 20 minutes. And the third one comes up 24 degrees, 12 minutes. Remembering the ratios. This is the key stuff. You get the ratio right, and then you use the correct type of problem, you won't make mistakes. So we have so, ka, toa. So, ka, toa. Types of problems. Unknown numerator. Unknown denominator. Unknown angle. Summary. 3 ratios, 3 types of problems. Unknown numerator, unknown denominator, unknown angle. So you've seen some of the trigonometry, types of problems, questions, and when you break it down into each step, identify the ratio correctly and then use the correct procedure. If you don't do that, you've got it covered.